Okay, week 7, day 2. I think what you will find as we are working through today's is A, it's short, and B, it's actually just a mix of all the solving we've done this far. Okay, so first off, important, okay, these two dates, Monday, May 18th and Tuesday, May 19th, it is required. I said that in my last video also, okay, but I just thought I'd remind you, required during your block to be there, okay? So I will see you next week in person. Here we go. We are solving rational equations still. Last day of it. What I want you to do is I want you to write down the question. And then I want you to give it a good look and contemplate and pause and see how you might decide you would start the question. Some of you may have said, hey, I want to make that 3 into a fraction, and you may have said, make that 3 over 1, and hey, that's perfect. A start to this question. So if you look at your denominators, give it all a good look. You may notice that 2 of them that are on opposite sides already have a common denominator. Okay? When I already have 2 with a common denominator, well, I can make it pretty easy on myself here. I can actually add that 1 minus 2x over x plus 2 to both sides. 1 minus 2x over x plus 2. Okay? When I do that, on the left, I'm just going to combine those numerators because they already have a common denominator. Okay? So that I have a negative x and a negative 2 over x plus 2 equals now 3 over 1. From here, there are actually 2 ways to go about this question. Okay, first off though, what can x not be? X cannot equal negative 2. Okay, right here, if I want to get them to be a common denominator, I can do this. I can go x plus 2 over x plus 2 so that I have this. When I have those same denominators here, I have a pretty basic equation. Oh, I don't need the over part anymore. Being a little silly. Okay, equals 3x plus 6. Solve the equation. Ooh, I got x equals negative 2. Up here it says x cannot equal negative 2. That means if x cannot be the negative 2, then my answer is this. No solution. Okay? Now, I told you there were 2 ways to solve this question. So I'm going to use blue here. No, I'm going to use red. Okay. And I'm going to go back to this step right here and show you an alternative route to this question. Okay? You could have actually done this on the numerator. You could have factored out a negative 1 so that there was an x plus 2 over x plus 2 equals 3 or 3 over 1. And you could have then simplified because, hey, look, those are the same. And now I have this. Negative 1 over 1 has to equal 3 over 1. Well, is that even possible? Because that's not possible. I'm still going to get that no solution. Okay, so 2 ways to do the question, same answer in the end. Question number 2. Write it down, pause, and factor anything you can factor maybe. Alright, there it is factored, and that's what we have. Hey, you may be looking at this question going, I don't have any that are the same, so I can't just add or subtract one to the other side or combine them. So the main goal here might be to get all of them to have a common denominator. If you look here, you notice that this one has a 2 and an x plus 2. That means that, hey, this one could probably use a 2 to make it the same. You may have also noticed that because this one here has a 2, this one also does not have the 2. Okay? Again, I want them all to be the same, so some of you may have noticed that, hey, this middle one has that x minus 1, but neither of the other two have the x minus 1. And finally, that middle one here is missing the x plus 2 that both of those other ones have. So a lot of multiplying happening here. On the numerator of this first one, I am just going to take the 5 and have 5x minus 5. Denominator is 2x plus 2, x minus 1, minus. Okay, so this middle one, I'm going to take the 1 times the 2 first. Okay, so now I have 2. The 2 is what's going to be distributed to my 2x plus 2 to get 2x plus 4. All over 2 times x plus 2, x minus 1. Again, on this far right side of my equals, I'm going to take the 3 times the 2 first, which is 6. Okay, so this one was a 1 times 2, which was 2, and the 2 is what got distributed. 3 times 2 is 6. That 6 is what gets distributed here to both of these, so that it's 6x minus 6. 2 times x plus 2, x minus 1. Now that all those denominators are equal, I can set my numerators equal. 5x minus 5. Pay attention here that I'm subtracting that whole 2x plus 4 because that can get you into trouble, equals 6x minus 6. Go ahead and solve that equation. And as long as you do not, x cannot equal negative 2 and x cannot equal 1. Alright, I got down here that x equals negative 1, and that is an okay answer to have. So there is my solution. Last question. I want you to solve it completely on your own. So I get this x equals negative 5. Up here at the beginning, there is no x value on the denominator. So that means x can be anything. There's no restriction on x. So x equals negative 5 is our solution. Hey, thanks for hanging in during these online learning sessions, listening to these videos. Hopefully they have helped you learn a little bit of something here in this Algebra 2 class. Just one last time reminder here that remember, next Monday and Tuesday, they are required that you are in class at your class time and on time, please. Have a great rest of your day.